Hello everyone, welcome to Maths Pidgin. The name never changed. The name is Mr. Maths. Today we want to do indices. For indices, you need small knowledge of algebra. You remember our algebra series now. So we will proceed from algebra series to indices. So now, we will start with the class if you are ready. Alright, indices. Now, if I take 2, multiply them by 2 like this, I'll get 4. Abi? And then if I take 2, multiply by 2, I will get 8. Abi? No be 6, so somebody say 6. No, no be 6. This one are 8. This one are 2 times 2 times 2. The one where you take 6 now. 2 plus 2 plus 2. Now that one be 6. When number multiply himself like this, right? We feel write am like this. 2 raised to the power 2. Like this. And then when number multiply himself like this multiple times, we will just write the number and then write small number on top like this. Then we will call this one, we'll be saying that how many times where the number they multiply itself, we'll call the power, right? This one now 2 raised to the power 3. This one now 2 raised to the power 2. Abi? Now you see, say 2 raised to the power 3, they're different from 2 times 3. Abi? This one now 2 times 3. More no confusion. 2 times 3 means multiple addition. I'm adding 2 multiple times. That's 3 times. That will give me 6. But this one, 2 raised to the power 3, means I'm multiplying 2 multiple times. If we don't express number like this, we don't express them in index form. Right? This one they index form, this one they index form. When we don't express numbers in index form like this, we don't express them in indices. Now, if we express number as 2 raised to the power 3 like this one, this 2, we will call them the base of the number. So these 2 are the base. And this power, as we don't talk before, we call them the power, or we call them index of the number, or we call them exponent of the number. So you express a number in index form, the number will get base, and you will get exponent, or index, or power. Now, why would they do this thing? Why are we expressing number? Somebody will say, if I multiply 2 by 2, now 4 now, why do I have to express it as 2 raised to the power 2? Abi? Somebody will say, if I don't multiply this and this one give me 4, and times 4 by 2, I'll get 8. I will write 8 now. Why do I have to express it as 2 raised to the power 3? You are right. You did right. But why do they express number like that? Now because of our algebra. So understand our algebra. Now, you get as it go be if we do algebra and we get number what we don't know, like this, A, come to multiply himself by A, like this. This one will feel like this. Abi, because now just A multiply A. What if the A come multiply himself multiple times, like 3 times, like this? Now so we go the right hand. You understand? If you write it like this, or A come multiply himself 200 times like this. Now so we go the right hand. So they occupy space. So now we go just write A raised to the power 2 here, and then we go just write A raised to the power 3 here, and then for here we go write 1, 2, 3, 4, 5. We just write there A raised to the power 5. So if we write them like this, we don't minimize space. And the day easier. Now make we do indices. Abi? Now, What I want to talk about now, as we don't understand this one now, what I want to talk about now powers of numbers and roots of numbers. If I get A now, we stand like this. It means say this A is raised to power 1. So the number we stand, it means say we don't raise them to power 1. From this expression now, it means say if my A multiply himself like this, I don't raise them to power 2. Abi? And then if my A multiply himself 3 times like this, I don't raise them to power 3. Abi? Now, if we dey do like this, you go be say if A don't multiply himself, waka, go reach, you understand? You reach any times. So make I write this one A1 2 times. You can't multiply himself reach any times where we know. So we go just say A raised to power n. A raised to power that time now. Abi? We just see A raised to power that time at the same. This one are the positions, no be different numbers. So. Now, as we don't establish these ones, now, what if we raise A to power 0? What if the answer will be? If we raise A to power 0, this one, now just thinking, I just a thinker, or somebody thinker, understand? Imagine say we raise A to power 0, what if the answer will be? We don't know that. This one another way or another skill where math is the reason, you understand? If something be, we go just imagine or reason some things. Even if we don't know, we leave am. Later we can't know what it be. So if I raise A to power 0, what it go be? We don't know, abi. What if I can't raise A to fraction? I can't raise am to power fraction. Maybe A raised to power 1/2. What it go be? You think I'm like that? We don't know that. Me, I don't know. But we'll concentrate or focus first for the ones who we know. As we don't establish these ones who we know, maybe we will answer these questions. Now, if we get A raised to power 2, they call them square. So that one another way of calling this power. Abi? If I get any number raised to power 2, we dey call am the square of that number. So this one now is a square of A. Abi? Square, we get am from this shape. You know this shape now? This shape, what do they call square? We get equal side. So the area of this shape, na him we dey use as this one. Because area, na this shape, or be this length, multiplied by this length. So as per say, the two lengths, they equal. So if I multiply the two, I'll get the area of this place. Now if you raise number by 2, they will call it the square of that number. We don't understand that one, right? How about this one? If I raise A to power 3, we will call it cube. We will call it A cube, because if I turn this shape now to solid na something where they 3-dimensional. I will explain if we talk about shape. Now, if I turn this square now to solid, then I will get 3 lengths will connect themselves equally, and all of them they equal. So this length and this length plus this length will go like this. So now if I take the volume of this solid, I will get A times A times A. So that one will give me A raised to power 3. Now if we raise number to power 3, we'll call them cube. If you raise one side of the cube or one length of the cube to power 3, you get the volume of the cube. When we talk about roots, roots, we dey denote roots as this, or the sign wey we dey take represent root na like this, right? And the least root wey we get na the square root, right? The least root wey we get na square root. Now, wetin be root? Root na opposite of power, or na opposite of how many times you raise number. Now, if I raise a by 2, abi, or if I multiply a times a, I will get a square, right? Now, this a wey I times am by a wey I get a square, this a now na the root of a square. So a now na the root of a square. Abi? So now, if I take a square and take the square root of a square, I will get a. Wetin e mean? E mean say if I take a times a like this, divide am by this a, I go get a. So if this one cancel, I go get a. Now the meaning of square root. So if I take 4 now, divide by 2, I go get 2. So these 2 na square root of 4. If I take 9, divide am by 3, I go still get 3. So 3 na square root of 9. Why? Because if I do 3 times 3, I will get 9. Abi? Now, if I get 49, if I divide am by 7, I will get 7. So 7 na the square root of 9. Why? Because if I do 7 square, that's 7 times 7, like this, I will get 49. So 49 na the square of 7, and then the square root of 49 na 7. Sure, we don't understand square root, right? Cube root means say if I raise number to power 3 like this, so a now na the cube root of a raised to power 3. Shall we understand? So now cube root will represent cube root as this one. This one is cube root, and the difference be that. So cube root of a raised to power 3 now a. What do you mean? It means say if I take a raised to power 3 divide by a, I go get a square like this. Then if I divide that again by a, I will get a. That means if I take this a, take this a, take this a, multiply all of them, I will get this a raised to power 3. So now the meaning of cube root. It means say there is a number. If I say find the cube root of 8 like this, it means say you get number where we say if I multiply that number by himself 3 times, I should get 8. And which number be that? So I will just say 8 times 2, I will get 4, abi? Then if I say, no, I say 8 times 2. 8 divided by 2, I will get 4, abi? Then if I divide them again by this same 2, I will get 2. So what's going to happen? It means say, if I multiply these 2, and these 2, and these 2, I will get 8. Therefore, 8, now the cube root of 8, now 2. Now, the next thing where I want to explain, now the nth root of a number. Nth root of a number. Abi? So, no mistake this thing, this one I just Oyibo. Nth root means any number root of a number. Remember when we do square root na 2 number roots of a number. Then cube root na 3 number roots of a number. Abi? When we do the nth power, when I raise number to the nth power, it means say any number power of a number. Shall we understand that one? Nth root of a number, we go denote them as this. We go make the sign are like this. So it means say nth. So any number root of a number. What do you mean? It means say if I get any number, or if I want find any number root, if na 5 number root I want find, I will just write 5. It means say the 5th root of that number. If na 10th root I want find, I will just put 10 here. So it means 10th root of that number. If I want 100th root, I will write 100th root of the number. Abi? So it means say I go fit write or check any root of any number or any number root of any number. Now we'll be waiting nth root mean. So it means say if I dey look for nth root of a number, so I go just decide, or as the situation decide, or warrant, say make I look for nth root of the number. So now we will take denote the nth root. So it means say if I get number x, it means say how many times I go divide them by this number to get this number. Abi? How many times I go divide? So maybe if I get number, make I make this number capital X. If I divide them by a, I will get small x. Then I will divide them again by a. I will get another small x2. Then if I divide them again by a, right, I will get another number until I will keep dividing. Abi, I will still divide them until I will get my answer a. If my answer, I will say the number of a's why I count like this plus the answer of a what I get. Now him be the number root of this number x. Now the meaning of nth root be that. Shall we understand? Correct. Now, as we don't understand roots and powers, make we do something. We want to do what they call laws of indices. Now, I want to reason these laws so that you can understand how we get the laws, so that you're not going to worry your head or disturb your head, say you want grammar, because you need these laws at your fingertips. You go correct? Is it on your fingertips or at your fingertips? Whichever one, you know you go with the speed, but you get my point. If I get this number like this, Abi, I can raise them to power 2. Then I can multiply the number again, can raise them to power 3 like this. Abi? But we do small algebra. But we just do small algebra. I just the reasoning. Abi? So what thing this one mean? It means say I get a times a, Abi, like this. Then I come times them again. A times a times a. Abi? Now what thing happen? Then if you remember our algebra say we multiply everything, Abi. So we just multiply a times a times a times a. Or they remove this bracket now. Times a times a. Abi? No, you like say don't pass. 1, 2, 3. 1, 2, 1, 2, 3. Now, then as I don't get it like this, then I will count how many A's I get. 1, 2, 3, 4, 5. So I will just say a raised to power 5. That's simple algebra. Now, what thing we can notice now? Notice the relationship between these indices, or between the exponents, now the powers. Now you see, as we can express them, analyze them like this for algebra, we can't get this thing. That means say these two powers they get relationship. So if we form shortcut, Abi, what is the relationship? This answer what we get means say we don't add this power. If I take 2 plus 3, shall not get 5. So if I can do 2 raised to power 2 times a raised to power 2 times a raised to power 2, I will just do the shortcut. A raised to power 2 plus a raised to power 3. Then I will get a raised to power 5. So I just take 3 easy steps instead of make I dey do all these things. E mean say if you get any number wey dem raise am to the power of x and the same number come multiply himself, this time they come raise am to the power of y. Wetin you go do be say you go just take the number and then add the indices. You go just add the indices. Na the first law be that. This one na law number 1. So this law, they call am addition law of indices or law of addition. What could this something again? If I get number like this, abi, and then I can raise am to, I don't know, power 5 like this, and then this same number I can divide the same number, when this time I can raise am to power 3 like this, abi, aha. If we do our simple algebra, we say a times a times a times a times a times a bar. Aha. Can they divide a times a like this? Abi? Aha. So this one will cancel this one. They will cancel out. I will get this one remain, abi? So I get a times a. And then if I do that one, I will get a raised to power 2. Now my final answer is that. Again, if we come check this power what we get with the relationship between these two powers, it means say if I take away 3 from 5, I get 2. Abi? Aha. From here, we can talk say if a is raised to power 5, can they divide a raised to power 3? It means say make I just take a raised to power 5 minus 3. You go just give me a raised to power 2. Now, what do you mean? It means say if I get number where they raise to some power, we can divide another number, we can divide the same number where I raise to power to another power. Then I will just take the number, I will just subtract the second number index from the first number index. So this law now law number 2. So we'll call this law subtraction law of indices or law of subtraction. This one said if I get number where I raise to power 2 like this, then if I can't decide say I want to raise them again to power 3 like this, it means say I get a raised to power 2 times a raised to power 2 times a raised to power 2. 3 times. Abi? Now what will be that? Aha. So if we break this one down now, we'll get a times a, abi? Like this. Times a times a, abi? Times a times a, abi? Now what you will get? Then we can break it down again. A times a times a times a times a times a. Abi? Aha. Now if you count them now, we'll get a raised to power 6. Now what we'll get for here. Then if we take this relationship of this power with these two power, it means that we just multiply 2 by 3. So we get 6. Abi? Aha. From there, we don't get law number 3. We don't get law number 3. Say, if you get any number where you raise to some power, they can't raise them again to another power. Just take the number and then multiply their powers. Just multiply their power. This one, now multiplication law. Law number 3, now multiplication law. Remember when I tell you, say, when we talk about powers, I can't say, what if I raise number to 0? What will the answer be? Okay, we see if we go fit answer this question. Abi? We go use law number 2. Know whether we go fit answer this question. So imagine, say, I get a raised to power 3. Then I can't divide them to the same a raised to power 3. Make we solve this one for algebra. See what we go get. What we go get, we get a times a, abi? Then divide by a times a, abi? So what is going to happen? It means say this one cancel this one, this one cancel this one, this one cancel this one. So what will happen? I get 1. Abi? Now what I will get now? This one is algebra. So it means say if I get a raised to power 3 divided by a raised to power 3. So if I do that law number 2, I will do a minus a raised to power 3 minus 3. I will come get a raised to power 0. Abi? So it means say a raised to power 0 now the same thing as 1. Because we don't use algebra, evaluate this one, we get 1. And then we can't use laws of indices number 2, evaluate this one, we can't get a raised to power 0. It means say if our math is correct, anything what we get for law of indices give us, then algebra is supposed to give us the same thing. So we do it for algebra, we get 1. We do it for laws of indices, we get a raised to power 0. So it means say a raised to power 0 now equal to 1. Any number where you raise to power 0 will give you 1. This one now, we call am 0 index. Now the law number 4 be that. The one question I asked that time. I said, what if I take number, can't raise them to fraction? What did the answer will be? Abi? Now waiting I talk with that. Sure you don't like this fraction? Me too. I don't like the fraction. So now I want to cancel this fraction. I want just cancel this fraction. How I go do? What I go do be say, as I get fraction like this, I want to cancel this 2. What I go do now to multiply by 2 bar. This 2 go cancel this 2. Abi? Now, what I can do from here? From here, what I do? It means say I don't raise this number to power 2. Remember our laws of multiplication. So if we get number raised to power this, and then we want to raise them to another power, say maybe we multiply the power. B. Now, I just multiply the power for here now. Everything I just do. So if I bring up this side, what I can't do? If I want from here come here, it means say I do like this. Abi? From here now, what I do be say I do a raised to power half times a raised to power half. Now what I do back? Correct. Then from here I will apply law number 1. We say if I get half like this, make I plus half. Abi? Now this plus this one will give me 1. Abi? It means say I get a raised to power 1. So we talk say if number is raised to power 1, the number now the same thing. Remember when I say a times a will give us a square, abi? It means say a now the square root of a square, abi? Now for this example, what I just do now, I just do a times a raised to power 1 over 2 times a raised to power 1 over 2. You can't give me a. It means say a raised to power 1 over 2 and the square root of a. Therefore, from this conclusion, we will say the square root of a, now waiting, a raised to power 1 over 2. So this one, now the 5th law. Abi? This one, now the law number 5. From there, we get fractional indices. That's or fractional index. That's law number 5. Abi? So the law number 5 say if I take a raised to power 1 over 2, make I just take the square root of a. And then if I take a raised to power 1 over 3, make I take the cube root of a like this. Then you say if I take a raised to power 1 over any number, then I go take any number root or that number root of a. Now, follow from this fractional index, we go get another law, what we dey call law number 6. Now, the law number 6 say, if I take a raised to power any number and then over any number like this, e say, make I take the nth root of a, then I will raise my answer to the power of that number x, where I raise e. Or I fit change my mind, then I go take the nth root of the number when I raise a to the power. But imagine say we can't raise a to -1. What do you mean? So what did this answer mean? We don't know abi. So we try algebra. Algebra say, and our second law. Our second law say if I take a raised to power 3, if you can't divide another a raised to power 4. So now I take a raised to power 3 minus 4. What will happen? You go give me a raised to power -1. I don't get negative indices for here, but so how we want to interpret this one? So a raised to power 3 divided by a raised to power 4 like this, mean a times a times a over a times a times a times a, abi? So you say this one will cancel this one will cancel this one will cancel this. What will remain? It remain 1 over a. Remain 1 over a like this. So now we use indices, we use law of indices. Can't get this one, a raised to power -1. Then we can't use algebra. We can't get 1 over a. It means say if I get negative indices like this, I will just express them as the reciprocal of the number. So this 1 over a are the same thing as a raised to power -1. That is the 7th law. So the 7th law, we call it negative index. So the negative index say, if I get a raised to power -1, make I take the reciprocal of a. If I get a raised to power -2, make I take the reciprocal of a squared. If I get a raised to power minus any number like this, make I take the reciprocal of a raised to power that number. Now the last law of indices be that. I hope say this class makes sense. Thank you for staying to the end of this class. If you get any question, ask me. Now if you don't get any question, try and familiarize yourself. Now use that Oyibo. Or try to get these laws of indices at your fingertips, abi, on your fingertips, so that you go use them when the need arise, because you go to use this one plenty for mathematics. Thank you. God bless you. Stay safe and stay subscribed.